Welcome back, everyone. I hope you had a nice break and that we are ready for our next keynote speakers. The next keynote speaker is Ayoub Fakir, lead data engineer at BData BChain. He was a keynote speaker at TED Talk in Marrakesh in 2017, where he talked about the blockchain paradigm. His talk topic is inventory management AI enabled. His motto is, I love failure, and when I fail forward. Before we get to AI, the data engineering part of any data project is crucial. In this talk, he will go through his experience designing from the PoC phase to the production project for a retail giant, going from millions of unstructured data to the unblocking of reporting, forecasting, and other AI use cases, enabling teams across the company to unlock their AI use cases. Thank you, Ayoub. The stage is yours.
Okay, hi. Thank you for attending this talk. My name is Ayoub, and I'm going to talk to you today about everything but AI. I'm sorry to disappoint some of you, but there are a couple of critical components for the success of any AI project, and those components do not usually include AI, and I'm going to go through that. So what is this talk about? This is going to be a talk of pure propaganda for data engineering for a lot of reasons. One of them is that I need a job. So, I mean, not now, but usually I have to find clients, so they have to know that data engineering is important. And the second reason is that it is actually important. So let's get into some propaganda. Anyway, there are two giants in the market today that are driving the data engineering agenda, namely Airbnb and Uber. And thanks to these companies, we can go forward with our data engineering journey and with our data engineering as a whole to be able to unlock use cases, including AI. And the quality of the content and articles that these companies publish every week, every day, just tells us how important this data engineering era is. So let's get into it and let's see how, thanks to AI, we were able to unlock a lot of AI use cases in a retail company. I'm not going to say the name of this company because I have sent an NDA and I am too lazy to go to jail. So let's enjoy some freedom while we can. What are the challenges? Actually, the problem that we have today is that people think that AI is some magical landscape that we just click on something and then it happens. Actually, it's not. It is cool, but the real work is done by plumbers. And by plumbers, I mean data engineers. Before we get to the AI part, where we can do LLMs, have machine learning models, etc., we have to make sure that our data is properly normalized, that we have a proper data lake that we can work with. And only then we can start talking about AI and other use cases. We're also going to talk about the data governance, what it means, why is it important and crucial for any data analysis slash AI project. And then, yeah, I mean, that's a given. If you train machine learning models with garbage data, you're going to have garbage results at the end. So that's something that we have to keep in mind. Here are a couple of AI use cases for retail. This is a non-exhaustive list, and this is only the list that we have worked on in this particular project and that we have unlocked and put into production today. So yeah, personalized product recommendations is the most known one, I guess, because we have to make sales, and if we want to make sales, we have to propose the right product to people, and if we don't do that, then we're just going to have a conversion of clients when we give ads, which is not terrible. Stores provisioning, which is very important because each store for any retail company needs to get some products from the warehouses in order for them to be able to do the sales. And ideally, we have to optimize this provisioning so they can have as little products left as possible at the end of the year for lots of reasons. Sales forecasting, very important for any company because that's the way for them to be able to, well, do forecasts. And that's one of the easiest use cases that we have. And then the last one is warehouse optimization for lots of obvious reasons. Okay, so for the context of the project, this is a project where we have approximately 1 billion transaction files generated every year, coming from more than 2,000 stores present in more than 70 countries. I think if you Google that, you can guess the name of the company, but anyway. We have more than 70 websites and marketplaces with different vendors. And we have a lot of ugly, very ugly XML data, and we're going to see why is that a problem. So that's the context of the project. When you go to the store, or when you go to the website, you buy something, and then what we get as data engineers is something that resembles this, which has no value / no sense. And our goal is to be able to make sure that we make sense out of this thing, because we receive an XML file with more than 340 fields multiplied by millions of this exact same transaction file. So we have to do something with it. We have to make sure that it makes sense to data analysts, because I have worked with a couple of data analysts. One of them is here present. And they're not going to talk to you if you give them something like that. So yeah, what are the issues with one transaction file? Well, the first issue is that the XML format sucks for a lot of reasons. Because it's textual, we do not have types, we don't know what's a number, what's a string, what's a date. And that's a huge problem. It's not the only format that sucks, actually. There are a lot of those, CSV and the likes. Yeah, that have no types, and that's a huge issue. The other problem is that we have more than 340 fields. Each of them is equally important sometimes, and we have to make sure that we monitor them to avoid, for example, aberrant values that we're going to talk about. And yeah, that's a huge problem. And then we have the other problem is that since we have more than 70 countries, each one has a couple of markets and then websites and marketplaces, etc. The data producers are different from one store from one country to the other. And we don't have any solution to that because for this particular company, some countries are not part of the main company. They are affiliates of the company, so they have different systems and different UIs, etc. So that's a lot of problem. And we have also a lot of manual entries, which is error prone, and we have to take care of that. The other issue is that we have, for each transaction, for it to be complete, we have to enrich it with other data. And anyone who has done data analysis or data engineering here knows the importance of enriching data with referentials. For example, when I get my transaction file, I have a country code, for example, which is 39, let's say. And 39 maybe is Serbia. And I have to get a referential which can make the glue between the fact that 39 is Serbia, and then I can do analysis, do group bias, whatever I can do. So we have a lot of referentials, more than 40 of those. Country codes, customer channel types, shipping methods, transaction channels. Was it from a website? Was it from a store? And each referential has its own challenges. Is it up to date? Is the quality of the referential good? And then I have to take care of all of these things, and that's a big problem. That said, the data between all of these sources need to be normalized. For example, if I have one referential which shows me a date which is different from the way I see it in my transaction file from another referential, I have to make sure that all of these data is normalized before I can move forward in my journey. Then there is the discussion about governance. Because, well, governance is a completely void word. It doesn't mean anything. And I usually stop listening to people who start talking about governance because we don't know what we're talking about. But if we just take these 3 points, which are, the first one is that we make sure that all the data consumers are aware of data schema changes. For example, if I receive one transaction file which had 340 fields and then I decide to add another field, maybe, I don't know, I don't have an example now, then all the consumers of this data set should know that there has been a change somewhere and it has to be communicated to them. We have to make sure that our alerting systems are up to date as far as the data quality is concerned. For example, aberrant values, and this is a problem that a lot of companies suffer from, including Amazon, for example, where if I go to the marketplace, sometimes it happens that I find, I don't know, slippers for 2 million euros, which is just a problem of data quality. It's not about the price of the slippers, unless there are some Balenciaga thingy. But that's one part. The second part is missing records. That's one of the most obvious / underrated data quality problems that we usually have, which is that, well, I get a transaction and it's lacking the date when the sales has took place. And what can I do with the transaction without a date? Doesn't make sense. Corrupt data in a lot of forms. For example, if I receive an amount, which is something other than a number, string in an amount, then it is a big problem. They have to take care of those issues as well, at scale for all the departments of the company. And the third point and last one is that when we talk about a data lake system, it's usually, I mean, it always means that it is used by a lot of people in the same company, and those people don't really speak the same language. For example, in IT departments, when I talk about warehouse, people think about some warehousing system where I can run SQL queries. If I talk about someone who manages a real warehouse, then when I talk about warehouse, he thinks about the place where he drives to go to work in the morning. So it's a different, we have to have the same vocabulary, and that's something very crucial to any data pipeline and to the governance of the data pipeline. The last thing is data partitioning. This is technical, I'm not going to talk about it much, but basically when I have consumers of data, even for the same data set, they need to access the data in different ways. For example, if I make queries and I filter by consumer ID, then probably that I need to have partition by consumer ID. If I do it by country, I have to have partition by country. And this is something that we can, that we have to take care about of. And there are some technologies like Databricks, for example, that offer us a lot of nice tools like Z-ordering that make sure that we can deal with that very easily. So data quality should be a core component of the pipeline. And as I said, each transformation needs to be closely monitored. We have to know what our transactions look like, our files, how they look like, what's missing, what's not missing, and have clear reports about what's happening, alerting, of course. Thresholds, which is a very important feature, because, for example, if I'm working with a company which makes ads, and I have, I don't know, 1 million ads coming in every hour, then if I lose data of 100 ads every hour, it's not a big problem, because, well, I have a lot of those. When I'm doing retail and sales, then I have to make sure that I have every single transaction, and if one is broken, then I have to make sure that it is not broken anymore. For a lot of reasons, taxes, for example, I have to know what my sales look like, etc. Yeah, that's what we talk about, errors management by design, in the sense that making a data pipeline is very easy. Everyone can just take data from point A, do some transformation, and put it to point B, and then we move on with our lives. But the problem is that data is usually very ugly. I mean, I have worked with a couple of companies before, and none of them had proper clean data, so I guess that's the way I'm going to continue having jobs. Data monitoring, of course. We're going to talk about data streaming and validation at scale in a moment, and then, of course, alerting, as we have said. So, just a quick word about the quality of the data pipeline. Usually I'm hired sometimes to make sure that, to audit, for example, data pipelines. And one way for me to be able to do that is going to the dashboard side or data science side. And if people have SQL queries that resembles this, they're not smart. It's just that the data pipeline sucks because it's not as simple as it should be for data analysts. That's a very important point. And this opens the door to a lot of unreadable SQL queries that no one wants to modify, and then they have freelancers to take care of them, and then they don't take care of them properly, and then it goes on and on. However, having some SQL query that resembles this means that the data pipeline has been properly done beforehand, because that means that the ugly work of pre-aggregating data, etc., has been done properly by data engineers. So if your data analysts have those kinds of queries, then kudos to the data engineers who did the work. A small anecdote that I had, which is that before we start working on this project, we had the data pipeline SQL-based. Don't do that. And we migrated from this thing. But the problem is that in one of the countries, we had a cashier that couldn't scan the code of a ball, probably. And then she had to put the code in the UI. She didn't click the right cell, and then she was in the price cell, and then she wrote the thing. We might argue that it's a UI problem because the validation should have been done from the UI, but that's what it is. So we got the data that flowed into our pipeline. No one saw that this thing was happening, and then we got a margin of plus, I don't know how many percentage. The price was in euro, so yeah. People were wondering, are we rich now, or is there some problem? So yeah, when you're on call and then the CTO calls you at 3 a.m. Actually, it was 8 a.m., but for developers, it's more or less the same. And you have to deal with that problem. Then you figure out that the work should be done properly, and this kind of aberrant value should never get into the dashboards in any way. Okay, a quick word about the data lake architecture. It's a very crude, simple one, where we have data that's coming in from a couple of sources. We have raw data written in XML. As I showed you, we have frameworks. We work, with frameworks like Spark, where we clean and make sure that the data is conform, that it can be used by the people who can use it. And then from then, we have what we call business level aggregates, which basically means that we have data in forms of tables that can be used by pretty much anyone, data scientists for AI use cases, data analysts, etc. And it's a very simple, crude, but an architecture that works all the time. How do we go from garbage to usable data models? So basically what you see here is one field in the XML called tags. And basically what you see there, without going into the details, this is written in Scala. We read the data as untyped. Basically, we say that every field is optional, so it may or may not be present, meaning that if it is not present and it is mandatory, then we'll have to alert and say that the amount of this transaction is not present, and if it's not, then the transaction doesn't make any sense. And every single field is a string. Without going into much details again, a string is an agnostic type where we can put everything in a string, right? And then once we get the amount, then we try to transform it to some proper type. So a number should be a double, 11.5. That's how it should look like. If it's not a double, then I have a problem in my data. And so in this way, we are able to have properly formatted data with types, with proper structure that anyone can use, and we can move forward from that. And we achieve that through what we have called the cascade validation. So basically, I have my top level is a transaction. So we have a transaction validator, and then from then, we have a couple of other validators until I arrive to the very last leaf of my XML file of my tree, which is basically the representation of a tree. And I have to make sure that every field is properly validated. And this gives us, this is just one part of our monitoring system, because today we have data analysts that basically work on the monitoring of the data pipeline. So we have graphs that show us, for example, how are the fields that are usually in error, so we can make sure that we can work on that. What is the frequency of the errors, and we can see every morning how the data quality of our data pipeline looks like. But basically here we have a simple table where I have an ID, which is composed of the transaction ID and the time of the sale. the status, the field that has a problem. So basically I have in the line before the last, I have a serial number which has a bad value for this transaction ID, and here is the bad value that I have seen. So I have to make sure it doesn't happen, and if it is important, then I'm going to act on that. So yeah, all of this to say that AI is the tip of the iceberg. Actually, the tip of this iceberg is bigger than what AI is, really. And the plumbing data engineering part is what's hidden. And that's why we see that in the market the tendency have changed, because in probably 2013, data scientists were considered as the wizards of the data, and they were overpaid. Now we are overpaid. So let's see how long this is going to last. Machine learning is easy because in this particular example, we have had a forecasting use case that we were able to ship into production in less than 2 months. The setup of the whole data pipeline, the monitoring, and all the other things took us more or less 2 years, and we're still working on that. So this is something to keep in mind. So if you hire some consultancy company and they tell you that they can have your AI use case shipped in 3 months, maybe they have, I don't know, ask yourself questions. And I think that this is how an AI project can be successful, because in all the AI projects that I have seen, all of those that were successful are those who had proper data engineering behind. That's the example, for example, of ChatGPT, because ChatGPT only implements a very simple LLM. That's something we all know, but their data engineering team is dope. And actually, it's one of the teams that wasn't happy about the CEO leaving, and they were threatening to leave, and made a lot of problems, because that's the backbone of any AI project. So takeouts, first of all, the AI romanticism, I think, needs to stop, because, well, everyone talks about AI, and usually, I mean, I don't know what AI is, so. The fact that OpenAI, for example, has succeeded before the data engineering was done properly. Putting AI and machine learning models into production is a matter of data engineering, not data science, because it's very easy for a data scientist to take a model and then apply it in 10 rows of data, and then, yeah, it works, hooray. But how can we scale? Because usually, especially in distributed systems, if it works for 10 or 100 rows, it's probably going to not work at scale. So this is purely software and data engineering problem that we are dealing with now. I think AI use cases get unlocked only when data governance is at the center of interest. We have to make sure that we talk the same language, and that's very important. And the last point is that designing and implementing the data pipeline, it's the easiest part. Again, everyone can get data, do some simple program, and then put the data outside, but having it well monitored and governed is another story. Thank you very much. You can reach out whenever. And
thank you, Ayoub, for this very insightful talk. Here is your certificate.
Thank you.
Of appreciation for your engagement at DSC Europe 2023.
Thank you very much. Thanks.
Thank you. Our next speaker will begin at 3:15.